Okay, so we're going to be going over graphing radicals, and specifically we're going to be going over one type of radical. We're going to be going over square root. So when we talk about a radical, our parent function is going to be y is equal to the square root of x. Now I could have a 2 here signaling that it's a square root, but the square root is an exception that the 2 is like invisible there. So if I had a cubic root, I'd need a 3. Or a quartic root, which means 4, I would need a 4. But with square roots, that 2 can be invisible. So if I don't know what this function looks like, the first thing that I can do is I can make my xy table. So if I make an xy table, I'm going to start with 0 in the middle, and usually I do -1. But I'm thinking if I plug in -1 for x, that means I'm going to have a negative number under a square root, which means imaginary. So when we graph, we don't graph imaginary numbers. They don't show up on our real axis. So that means anything negative, I'm not even going to be able to graph. So I'm going to have to choose all positive numbers. So I'm going to say 0, 1, and then I'm purposely going to say perfect squares to make it easier for me to graph. So I know 2 squared, so if x is 4, the square root of 4 would be 2. So I'm going to say 4, and then I'm going to say, I know that, let's see, 3 squared is 9. So I'm going to say x is 9, because the square root of 9, that would be 3. Okay, so I'm going to plot these 4 points. So if I'm solving for y, I'm going to have, this is going to be y is equal to the square root of 0. The square root of 0 is just 0. And then I'm going to have y is equal to the square root of 1. Well, I know 1 times 1 is 1, so that means the square root of 1 is 1. And then I'm going to have y is equal to the square root of 4, so that means 2. And then y is equal to the square root of 9, which is 3. So I have 1, 2, 3. So I'm going to plot those 4 points to see what this graph looks like. And I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And then this is going to be 1, 2, 3, 4. So 0, 0, I have a point there. 1, 1, I have a point here. And then I'm going to have 4, 2, so 1, 2, 3, 4, 1, 2, and then 9, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, and I know I can't have any negative numbers. So we talked about how I can't have a negative under that square root because it'd be imaginary, so I can't have anything to the left side of my y-axis, and my graph looks like this. So when you have radical functions, it'll always just be this little swish, swish, swish. All right, so now let's talk about the domain and range. So if I want the domain, when we're talking about a domain, that means my range in x values. We're talking about x with domain. So if I have nothing to the left-hand side, that means x will always be positive numbers. So that means x is touching 0. So that means x is equal to 0 or greater than. And we can write that as this. X is greater than or equal to 0. Now let's talk about the range. The range, we're always focusing on the y values. So do I have anything below in my negative y values? Nothing. This graph will never have negative y values, but it will keep on going. Even though this looks like it's just going off to the right, it's still curved, so it's still eventually going to keep on going off into infinity in the y direction as well. So we have y is greater than or equal to 0. That's our domain and range. Okay, let's do a couple other examples, and we're going to do some transformations. So if I have y is equal to the square root of x minus 1 plus 4. Well, I'm just going to use this parent function. So now I'm going to skip the xy table. But if you feel more comfortable with the xy table, then do it every time. It'll work every time. This plus 4 out here means we're going to be going up 4. And this, just like what we had before with our h comma k with quadratics in our parentheses. This is going to be the opposite. So when we think of under the square root, we think of the opposite. So because this is a -1, it's actually going to be a +1 to the right. So if I'm doing a quick sketch of this, I'm going to go start 1 to the right and up 4. 1, 2, 3, 4. That's where I start my little swoosh, and from there I can estimate it. Swoosh. So my domain, it starts at a +1 and then goes off to the right. So that means x has to be greater than or equal to 1. And my range doesn't start at 0 like it did here. It starts at a +4. So y is greater than or equal to 4. Sorry about that though. Let's do another example. Y is equal to the square root of x plus 2 minus 3. So this means that I'm going to go down 3, and this is the opposite. So I'm going to say 2 to the left. So this is going to be like a -2. So if I'm sketching this, my x value, I'm going 2 to the left and down 3. 1, 2, 3. I put my point there and swoosh. So if I'm talking about my domain, that means my domain, here I start at a -2 and then go to the right. So x is greater than or equal to -2. And for the range, I'm going down 3, so y actually starts at a -3 and then goes up. So y is greater than or equal to -3.